Hello everyone, welcome to the solution of LeetCode problem 116 named Populating Next Right Pointers in Each Node. Here, you are given a perfect binary tree where all leaves are on the same level and every parent has two children. The binary tree has the following definition. It has a value, left node, right node, and the next pointer. Now, we have to populate each next pointer to point to its next right node. And if there is no next right node available, the next pointer should be set to null. Initially, all next pointer are set to null. So here, let's consider this first example. The root is 1, which has two children, 2 and 3. 2 has two children, 4 and 5. And 3 has two children, 6 and 7. Now, this node 1 will point to the null. This node 2 will point to the node 3. And this node 3 will point to the null. This node 4 will point to the 5. This 5 will point to 6. 6 will point to 7. And 7 will point to null. I hope you understood the problem statement. Now let's move on to the algorithm. To understand the algorithm, we have taken the same example. Now, how can we basically solve this problem? This problem basically solved using the BFS. Why we are using the BFS? Because we are connecting the nodes into each of the level. As 4 is connected to 5, or we can say that the next pointer of 4 is connected to 5, the next pointer of 5 connected to 6, and 6 is connected to 7, and 7 connected to null, and so on. So here, basically, we are connecting the next pointer into level by level manner. So in the graph theory, when there comes level, we will use the BFS. And to implement the BFS, we will use the queue.s structure. Now let's start the BFS from the root node 1. So 1 will be inserted into the queue. And so we can say that this is the first level and it has two children, 2 and 3. So both of them will be inserted here into the queue. Now we have to remove 1. So does 1 is the last element of its level? Yes, it is. So 1 will be connected to null. Or the next pointer is connected to null. Now our next level in 2 and 3. So our top element is 2. So 2 has two children, 4 and 5. We have to insert it into the queue. And we have to remove 2 from the queue. So now does 2 is the last element of its level? No, it is not, because in the second level, it has the element 3. So we will connect 2 with 3. That means what is 3? 3 is the top element or front element of the queue right now, because 2 is removed. Now we are at this node 3. It has two children, 6 and 7. So we have to insert it here. And does 3 is the last element of its level? Yes, it is. So we have to connect it to the null. Now we have to remove 3. Now our next level has 4 nodes, 4, 5, 6, 7. So what is the top element of the queue? It is 4. And we have to remove it. And we have to connect it to 5, which is the front element of the queue, because 4 is not last element of its level. Similarly, currently we are at this node 5. So 5 is connected to 6 and 5 is removed. Now we are at this element 6 and 6 is connected to 7 and 6 is removed. Now we are at this element 7. Does 7 is the last element of its level? Yes, it is. So 7 will be connected to null. Or the next pointer of 7 is connected to null. And finally, we remove 7 here. So we can say that this tree is modified and all of the next pointer is connected here. So we have populated the next pointer by using the BFS. I hope you understood the algorithm. Now let's move on to the code. Here, to understand the code, we are given a function named connect, which is a node root as a parameter. Now we are taking a queue of this node, and if currently we have to insert the current root into the queue for the BFS, and while queue is not empty, we have to calculate the size of the queue, which is the size of the each level, and we have to iterate for each of the size and store the current element of the queue into a variable current. And we have to remove the front element if the current element has the left subtree. We have to insert the left subtree into the queue, and similarly for the right subtree. And if our current element is the last element of the level, the current element's next pointer set to be null. Otherwise, current element next pointer will be initialized with queue's front. Finally, we have to return the root. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.